All right, section 8.2, combinations. So before we were talking about permutations, we're talking about the number of ways you can arrange things. But combinations says, okay, what happens if we don't care about the arrangement? I only care about the number of ways that I could do something, and without arranging them. So if I'm talking about taking 3 of my 5 books and putting them on the shelf, I don't care which books they are or which order they're in. I just care about which the 3 books are showing up. I have some examples here. I said if the 3 books that are chosen are mystery, biography, and textbook, then it looks like six different possible arrangements that we could end up with those. And if I was to say, okay, what's 5 permute 3? Well, 5 permute 3 is 60. But essentially, I'm getting, no matter which 3 books I choose, there would be 6 different ways I could have arranged those books. So I'm kind of getting this 60 is 6 times too big. It's, it's no matter which 3 books I choose, I'm arranging them 6 different ways. And so in total here, what we could do is I could then divide by 6. I could say that 60 divided by 6 to get, well, it looks like 10. So this is actually where this formula for combinations comes from. Combinations, we use the same formula for permutations. You can see there's the n factorial and n minus r factorial. But then we're saying we're going to have an additional factor of r factorial in the denominator, saying all the different ways I could have arranged the things that I picked. I'm essentially overcounting them. You can almost think of these in the same sense that we did the distinguishable permutations. So we end up with r factorial on the bottom, an additional r factorial. Again, this is something, this formula you don't really need to know very well. You don't even need to be able to recognize it, because you're just going to be plugging stuff into the calculator. You do need to recognize when it's a combination versus a permutation. The big difference between combinations versus permutations is with combinations, order doesn't matter. With permutations, order does matter because we're arranging them. With combinations, order doesn't matter. We're not arranging them. We're kind of dividing off this thing, all the different number of arrangements we could have done. There are some useful combinations to have memorized. Again, plugging these things into the calculator is not trivial. So some of these numbers end up popping up quite a bit. So if you have, let's say, 6, if you have 6 books and you're choosing 0 of them, you're trying to figure out the number of ways that can happen. Well, there's only one way that happens. That's the same as not choosing any of them. And actually, through symmetry, not choosing any books is the same as choosing all 6 of those books. There's only one way to choose all 6 of the books. You choose all 6 books. So you can almost imagine this, you have your 6 books, you're dividing them into 2 different piles. You have all 6 of them over here and 0 of them over here. There's only one way to do that. You have all 6 of them over here and none of them over here. So that's kind of talking about both of those. What happens if instead of having all 6 in one pile, I want to have 5 in one pile and 1 in the other pile? Well, there's 6 different ways to do that. There's one for each of the different books. So in general, n choose 1 is n. But this is the same as saying, okay, the number of ways to choose 5 books, because that's 5 books in the other pile. That's also n choose n minus 1 is also n. So if you were to see something like, I don't know, 20 NCR 19, this would be 20. The number of ways, if you have 20 items, the number of ways to choose 19 of them is 20. You essentially choose one item to pick out of the list.